All right, this section we're taking a look at distance and midpoint formulas. We do start out with plotting some points. So just a review from last time, if we're plotting -1, 4, we're going left 1, up 4 from the middle, right? X, Y, X is right, left, Y is the up or down. So -4, -2 would be left 4, down 2, and so on. There's our -4, -2. And this is our quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So -1, 4 is in quadrant 2. Let's do 3, -2, right 3, down 2. That's in quadrant 4. Let's do 0, -3. That's not in any quadrant. It's right on the y-axis. And finally 2, 3, right 2, up 3. All right, the distance formula. The distance formula comes from the Pythagorean theorem. If you remember, if you have a right triangle, a squared plus b squared equals c squared. You guys remember that? A squared plus b squared equals c squared. So in other words, the distance from what I'm going to call x1, y1 to x2, y2 would be this distance c, right? So we would solve for distance c by taking the square root. So the square root of a squared plus b squared would be the c distance from x1, y1 to x2, y2. Well, if you look at this, I'm just developing this. You guys are showing you where it comes from. This length a is this x2, here's x2, and here's x1. It's x2 minus x1. That's the distance a. And then if you look at this for b, this is the y. That's y1 up here to y2. So it's y2 minus y1 is distance b. Oops. And that's our distance c. So we just call it the distance d instead of using c. There's our distance formula. So let's go ahead and use that again based on the Pythagorean theorem. So here's -2, 4. What's the distance from there to 1, 6? What's this distance d? So we plug it in. Let's find how long that line segment is. I'm going to name this x1 and y1. I'm going to name the next one x2 and y2. And now I'm going to plug that in. Distance is x2 is 1 minus x1 is -2. And then y2 is 6. There's our y2 minus y1, which is 4 squared. So 1 plus 2, I got 3 squared plus 2 squared. So I got 9 plus 4. So I got square root of 13. Well, square root of 13, 0 square root of 0, 1 square root of 1, 2 is the square root of 4, 3 is square root of 9, 4 is the square root of 16. So this is 3 point something, a little bit closer to 4. Let me punch it in actually. Square root of 13 is 3.6055. If you were to punch it in, right? But exact form is the square root of 13. All right, that's how you find the distance between 2 points. Now, if you're finding the midpoint between 2 points, the halfway point, so it takes going from x1, y1 to x2, y2. What it does is it finds the average between x1 and x2. So x1 plus x2 divided by 2 would be, let me do it in green here, be right there. That's the halfway point between them, x1 plus x2 divided by 2. And then the y1 plus y2 divided by 2 would be between y1 and y2. So y1 plus the average of those two. Okay, so let's use the midpoint formula to find the midpoint between 2, -3. Let me just graph this. 2, -3, and 4, 4, 2. Okay, so the midpoint between those two. So I name it x1, y1, x2, y2, and the midpoint is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So our x1 is the 2, and the x2 is 4. So I get 2 plus 4 divided by 2. And then the y1 is -3 plus 2, all divided by 2. Well, 2 plus 4 is 6. 6 over 2 is 3. -3 plus 2 is -1 over 2. So 3, comma, -1/2. So here's a midpoint. 3. So if you go over 3 and down a half unit, can you see how that's the midpoint between the two? So that's distance and midpoint. Now let's take this point 11, 14 and shift it 5 units to the right and 2 down. Okay, so here's 11, 14. If I go 5 to the right and 2 down, where am I at? Good, good. Yep. So 5 right, 2 down. So that'd be a 5 to the right for the x, 2 down for the y. So 16, 12 would be my new xy. Right, that'd be the new xy. Would be 16, 12. Right. Well, that's it for this section. Let's go ahead and work some of these distance, midpoint problems, plotting, and so on. Thanks for watching.